Specific water pump installation instructions vary depending on the make and model for your engine. For mechanical water pumps, there are two basic types. Pumps with a sprocket, like this one, are driven by a timing belt or a chain located behind a protective cover that surrounds the crankshaft and the camshaft. Other water pumps are part of the accessory belt drive system, are powered by a V-belt or a serpentine belt. Installation procedures differ dramatically depending on where the pump is located. But regardless of which system you're working on, here's the first critical step that applies to all water pump replacements. Step 1. With the old pump still on the engine, drain the coolant and completely flush the system. Do not flush the system after installing the water pump, since contaminants will be forced into the new pump, causing damage to the seals and creating leaks. If the coolant shows a lot of suspended solids like rust and scale, you should take more aggressive action and power flush the system using a power clean flush tool. Failure to remove contaminants before installation will shorten the life of the new pump. Step 2. Remove the old water pump by removing the bolts in a crisscross pattern. Note the position of any bolts with thread sealer, since that bolt may screw all the way into an open water jacket. Examine the old pump to determine the condition of the impeller and housing. Broken or missing vanes on plastic impellers may have settled into the bottom of the engine block and may need to be retrieved. A cracked housing around the bearing shaft may indicate heavy vibration from an imbalance caused by a worn fan clutch or bent fan. Correct these problems before installing a new water pump. Step 3. Protect the system from debris by inserting a shop rag into the block opening and scrape off the remains of the old gasket and sealer. The mating surfaces must be completely clean, smooth, and dry before installing a new pump. Step 4. Coat both sides of the new gasket with an oxygen sensor safe gasket sealer if required, and place it on the pump or engine block. Metal gaskets do not require sealant of any kind. Position the pump on the engine and install the mounting bolts. Any bolts with thread sealer should be cleaned before applying a new coat. Reinstall in the original location on the engine. Bolts should be tightened in a crisscross pattern using a torque wrench. Check manufacturer recommendations for the proper torque settings and hand tighten only. Never use air tools on a water pump. Step 5. Check the pump to make sure it rotates freely. Hoses and belts should be inspected for wear and replaced as needed. Radiator hoses should be replaced every 8 years or 80 to 90,000 miles to avoid failure. To save money, replace the coolant hoses when the water pump is replaced, since there's no additional labor required. Eliminating a future labor charge will more than pay for the cost of the hoses now. When installing a new serpentine belt, the automatic tensioner should be replaced at the same time. Refill with a 50-50 or 60-40 mixture of antifreeze and distilled or deionized water, according to your location and OE specs. Always refer to the car manufacturer's recommendations for the application-specific coolant. Using a vacuum assist tool will help remove any air which may be trapped in the system. Step 6. Turn on the cabin heat and run the engine for 15 minutes until the engine has reached operating temperature and the thermostat has opened. Shut off the engine and check for leaks. You may notice some drops at the weep hole, which is to be expected. All new water pumps require an initial run-in period that allows the seals to properly lap in. During that time, a small amount of coolant may leak through the weep hole. This is normal and will stop after the seal surfaces fully mate with each other. The weep hole is part of the pump design that allows a small amount of coolant to lubricate and cool the seal surfaces and then exit the pump through this passageway. The seal is the most critical part of your cooling system. It is a mechanical assembly mounted directly behind the impeller that keeps the coolant from entering the bearings and destroying the pump. Inside the assembly are two carbide composite rings. The front ring spins against the stationary back ring. A stainless steel spring maintains constant pressure between them to keep coolant from damaging the bearings, but still allows a small amount of coolant to lubricate and cool the ring faces. Without this lubrication, the seals would overheat and fail. Over time, drops of coolant can stain the area around the weep hole or drop to the garage floor. This normal weepage is sometimes misinterpreted as a defective seal resulting in premature water pump replacement. To solve this problem, OE manufacturers have revised some water pump designs to include a weep chamber. As the normal capillary movement of lubricating coolant moves across the seal faces, it collects in this chamber and evaporates over time. This new design reduces customer comebacks and warranty claims for pumps that are just doing the job they were designed to do and are not defective. If cooling system contamination does damage the seal on this new design, coolant will fill the chamber and exit through a hole at the top. If that happens, a cooling system flush and water pump replacement are necessary. The best way to protect water pumps from premature failure is to maintain a clean cooling system and flush the system before a new water pump is installed. If the coolant is contaminated with suspended rust, scale, or other minerals, a pressurized system can force these contaminants between the seals where they can scar the highly polished surfaces. Here's what a new seal looks like under a microscope. And here is a seal that has been damaged by contaminants. Notice the circular path as they move across the spinning seal. Contaminants as small as 50 microns, less than the width of a human hair, can score the seal surface, allowing coolant to leak past in larger quantities. Once scarring of the seals begins, even larger particles can enter between the seal faces, leading to excessive coolant loss that backs up into the bearing race past the bearing seals. Coolant can wash away the high-temperature grease, which will result in overheating of the bearings and potential seizing of a pump. A seized pump can break a belt, resulting in expensive damage to other components. If the belt is a timing belt, expensive damage to valves, pistons, heads, and cylinder walls may require replacing the engine. No wonder they call the water pump seals the most important part of your cooling system.